Hi guys, this is your introduction to the control plane programming assignment. You will find it up here in the control plane branch, or just by clicking here for control plane. Okay, so in this lab you will design a control packet to communicate your routing tables, implement a distance vector routing protocol, and control routing using cost links. To start with this assignment, I'm providing you guys with the network layer and the data link layer, network PY and link PY respectively, and simulation PY, which will run the different elements of the network and drive traffic in this simulation. So the basic simulation, the basic network we're starting with is here in this figure. We have a host, router A, router B, and then host 2. And here are the interfaces through which they are configured. You will see that in the code later on. The interfaces are bidirectional. Okay, so simulation PY defines the host, routers, and link. Hosts will generate traffic, and then routers forward the traffic between the different interfaces. And of course, the routers will also exchange routing tables to establish forwarding paths. This is the core of the assignment. And then the link layer forwards data between the different interfaces. Okay, so to start this program, you will say Python simulation PY, which will start executing. So, okay, so maybe before going over the rest of the assignment, let's start by taking a look at the code. So here is just another window open to the same branch, and we'll start with simulation.py. I'm going to zoom in here a little bit to make this easier. Okay, so we have the usual import suspects, and we start the main function by creating the different hosts. I've done some renaming here since the last version of this assignment. So we have host 1 and host 2, which matches the figure. From there, we define the two different routers. And the big update is that now we have this table, the cost table, instead of the routing table, with the routing table being built by the router itself. So the cost table maps a neighbor, so each router has some neighbors, and the cost table tells you which neighbor is connected over which interface at what cost. Okay, so here, for example, we're connected to host 1 over interface 0 at cost 1. Okay, so router A is connected to host 1 through interface 0, and here we're saying that the cost of this link is 1. Okay, similarly, router A is connected to router B through interface 1 at cost 1. Okay, so we define router A, and then we define router B with its own routing table. Notice now that the connection to host 2 is going to be at cost 3. Okay, from here we start the link layer and add the different links. The key thing to remember is that these links need to reflect the connectivity in the table above, right? So if host 1 is connected to router 1, this connection has to be over interface 0. Hosts just have interface 0, but it has to be to router A interface 0, which is reflected over here. If these don't match up, then this network is not going to work. Okay, so then we start all the object threads, and the first thing that happens is we'll start by computing the routing tables. So to do that, we will basically have any of the router start sending a route, and that will trigger all the other routes to respond with their route updates to their neighbors, and eventually, if we execute this for long enough, then the tables will converge, at which point we will print them out for inspection. Thereafter, we can send a message from host 1 to host 2. Again, wait for it to be delivered, and finally we shut down this simulation. Okay, so the second file to go over is network.py. Okay, and this is quite similar to the original assignment. We have the interface, which has in queue and out of queue, and basically forwards data from between the queues. Okay, and then we have network packet, which we will transmit between the different elements of this network. The thing to keep in mind is that we have this protocol length field. Okay, so depending on what type of packet you're sending, you will define this protocol field, and this will either state that the packet is a data packet, or that the packet is control packet. So your data packets will obviously fit in here, but if you're transmitting a routing table, then you set the control to be equal, the packet to be of type control, and then your router can know the difference and process either forward one or process the other as a routing table update. Okay, so then host is without change. We can initialize the host that has one interface 0. And then it can send packets, receive packets, and then run starts the thread. Okay. Then we have the router class, where you will be doing most of the work. And here we initialize some variables, and we set up the interfaces, okay, based on the length of cost D. Okay. So however many your neighbors you define, that's how many interfaces here will be created. We're going to save the cost D for later. You'll probably need it, hint, hint. And we're going to initialize the routing table. Okay, initially, I'm just going to say it's an empty dictionary, and it's your job to figure out what the initial routing table should be, and then print it after it's initialized for your own inspection. Okay, so then we have process queues, which basically decides whether or not a packet, depending on its type, depending if it's a data control, is going to be forwarded, or if it's going to be used to update routes. And so we're going to pull data out of the in interface, and then for each packet, we're going to send it to one of these functions. Okay. For forward packet, this is where you're going to do the work of looking into your routing tables to figure out which interface to forward the packet on. Right now, we're just forwarding it out interface 1. Okay. And then we have the two routing functions. So for send routes, you will figure out what is the routing packet that you need to send that contains your routing tables according to the distance vector algorithm. Here we're just sending a dummy routing table. You will need to replace that with something more clever. And this just sends the packet on the out interface. You will, as a hint, you probably want to send it on all the interfaces when you modify that. Okay, so then for update routes, you receive the packet and you need to merge it, the routing update you're getting from somebody else, with your own routing table. Finally, here's a way to print routes. Right now, this only prints the dictionary. I want you guys in the assignment to print something else. I'll describe that in a second. And then the run, of course, starts the thread. All right, so the last file in the simulation here is going to be link.py. This basically has no changes, but I'll go over it anyway. So we have a link, which is between one node and another node, and one interface of that node and another interface of that node, as defined in simulation py. Okay, and what basically this does is it just transfers the packet from one interface, from one of these endpoints to one of this endpoints. Okay, and then the link layer basically calls this transfer packet function on all the links in the link layer, and here's the function that starts that thread. Okay, so let's go back to your assignment. Okay, so what I want you guys to do is as follows. So for part one, just for 2 points, I want you guys to implement the print routes function, which prints a pretty table. What I do want is a table view, and here I sort of describe the structure of it. Basically, here you have the router from which this table is printed. Here you have all the different destinations, including other routers, and here I have the other routers in this network that are known to this particular router. Okay, this will be important later on. And then here you have the costs. So the cost is that router A knows that it can go through router B at cost 2 to destination H1. Okay. So this table will be useful in debugging your routing algorithm. Okay. So the next step for point 2, I want you guys to implement the send routes function that sends routes correctly according to the distance vector protocol. And then part 3 is going to be update routes such that you can accept one of these route updates and update your local routing tables. What you will submit is a YouTube video that shows a link to simulation, that shows the execution of simulation PY until the tables converge. So at that point in simulation.py, over here you'll see that once tables converge, we print out all the routing tables. So we will look at those and determine if your distance vector algorithm correctly converges the tables. Okay. The next 2 set of questions depend on or ask you to forward packets in the simple network, okay, and then send the packet back from host 2 to host 1. And what we want to see is then a YouTube video for points 4 and 5 that showed the execution of packets being forwarded along with the output that shows the forwarding decisions made by the different routers. We want to make sure that your routers are forwarding based on routing table, not based on stuff being hard-coded. Okay? So then the last part of the assignment, part 6, before the bonuses, is to set up this network. Okay, and then your job is to make sure to configure the routing paths or routing costs of the different links such that the packets from host 1 to host 3 follow a different path than packets from host 2 to host 3. I'm sorry, I misspoke. Packets from host 1 to host 3 need to follow a different path than packets from host 3 to host 1. Okay, so the forward and reverse paths need to be different. Okay, so you need to configure that, and then third YouTube video, and the output needs to show the final routing tables for this table, for this network, and the forwarding decisions made by the different routers. Okay, and this is the third part of the code you will submit. So I guess as far as the code goes, for each video you will submit separate pieces of code that comprise your solution. Okay. And then we have 2 bonuses. One asks you to encode IP, to support IP addresses instead of the H1 and RA or H2 and RA types of naming schemes. And then the last scheme asks you to implement, or the last bonus asks you to implement IP multicast among the group of 3 hosts in this network. Okay, good luck.